Have you ever imagined stepping into a machine, pressing a button, and suddenly finding yourself in a different era? Witnessing dinosaurs roaming Earth or walking the bustling streets of 1920s Paris? Time travel has fascinated humanity for centuries. From H.G. Wells's imaginative tales to the blockbuster sci-fi movies we can't get enough of. But what if I told you that time travel might not just be a fantasy? Could we, in some way, bend the fabric of reality and move forward or backward in time? Today, on Cosmic Horizon Hub, we're diving deep into the mysteries of time itself, exploring whether traveling through it is science, speculation, or pure imagination. So, buckle up, because the journey we're about to take will stretch your mind across the cosmos and into the very essence of existence. Time is something we all experience, tick-tock, day after day. But what is it really? Philosophers have debated it, scientists have measured it, and poets have tried to capture it. In physics, time is often described as the fourth dimension, intertwined with the three dimensions of space to form what we call space-time. Imagine space-time as a giant flexible fabric stretched across the universe. Objects like stars, planets, and black holes sit on this fabric, curving and warping it with their mass. Albert Einstein's theory of relativity tells us that this warping affects time itself. The stronger the gravity, the more time slows down. This isn't science fiction, it's a phenomenon called time dilation. Astronauts on the International Space Station experience it daily, aging just a tiny fraction slower than we do on Earth. Now that's a taste of time travel into the future, but only by milliseconds. But what about traveling further, much further into the future? Or even into the past? Let's first look at traveling forward. According to Einstein, if you could travel close to the speed of light, time for you would pass slower compared to someone left behind on Earth. Picture yourself in a sleek, futuristic spaceship, engines roaring, streaking past stars at near-light speed. Hours aboard your vessel might equal years back on Earth. You could theoretically jump decades or centuries into the future, witnessing the rise and fall of civilizations. This isn't just imagination, it's grounded in real physics. Scientists call this relativistic time dilation. And though our current technology can't achieve near-light speeds, it's a principle that has been repeatedly confirmed by experiments with particles moving at high velocities. Now, traveling backward in time presents a far trickier challenge. Why? Because it conflicts with something fundamental in physics: causality. The idea that cause precedes effect underpins everything we know about the universe. If you went back in time and accidentally prevented your grandparents from meeting, would you still exist? This is the famous grandfather paradox. Physicists have debated it endlessly, and some suggest that the universe might protect itself against such contradictions. Others propose that alternate timelines or parallel universes could resolve the paradox, meaning if you traveled back, you might simply create a new branch of reality. Imagine a cosmic tree, each branch representing a different timeline. Cut one branch, another might grow in its place, leaving the original intact. One of the most tantalizing possibilities for backward time travel comes from a concept called wormholes. Wormholes are hypothetical tunnels connecting two points in space-time, potentially allowing shortcuts across vast distances or even across time. Picture space-time like a piece of paper. If you fold it and punch a hole connecting two spots, you could travel instantly from one point to another. Some solutions to Einstein's equations suggest that traversable wormholes could exist, but there's a catch. These structures would require exotic matter with negative energy density to keep them open, something we have yet to create or find in nature. Without it, a wormhole would collapse before anything could pass through, crushing any traveler into oblivion. And even if we could stabilize a wormhole, we still don't know if it would allow backward time travel or just fast travel through space. Then there's the mysterious case of cosmic strings. No, these aren't strings you find in your wardrobe. Cosmic strings are hypothetical one-dimensional defects in spacetime, thinner than an atom but immensely dense, left over from the early universe. Scientists theorize that if you could move around these strings at incredible speeds, the warping of spacetime could, in theory, allow closed time-like curves, essentially paths that loop back in time. Imagine riding along an invisible cosmic racetrack that bends so sharply it loops into yesterday. The equations suggest it's possible, but the practical challenges are monumental. You'd need energy levels beyond anything we can currently generate, and getting near a cosmic string might obliterate you instantly. Let's not forget the strange world of black holes, the universe's ultimate time warp machines. Around a black hole's event horizon, gravity is so strong that time nearly comes to a standstill relative to an outside observer. If you could somehow hover near this edge without being torn apart, you could watch the universe age billions of years, while you age only moments. But venturing too close means certain death. And if you were thinking about going inside a black hole to travel to the past or future, the laws of physics become murky, and we enter the realm of speculation. Some theories suggest black holes might be portals to other universes, while others propose they could end in singularities where time and space cease to have meaning. It's a cosmic enigma, one that challenges our understanding of reality itself. What about the quantum world? Could the strange rules of quantum mechanics offer a loophole for time travel? Quantum physics allows particles to exist in multiple states simultaneously, to tunnel through barriers, and even to become entangled across vast distances. Some physicists speculate that quantum effects could allow for microscopic forms of time travel, like sending information, tiny bits of data, backward in time without violating causality. This is called quantum retrocausality, and while it sounds like pure science fiction, experiments have hinted at the possibility of particles being influenced by future events. However, scaling this up to humans or large objects is an entirely different challenge, and likely impossible with anything close to current technology. Time travel also raises profound philosophical questions. If we could visit the past, should we? Would changing history be ethical or even safe? The butterfly effect, a concept from chaos theory, tells us that small actions can have enormous consequences. Alter one tiny event in the past, and the ripples could reshape the entire future. Imagine stepping on a butterfly in prehistoric times, and billions of years later, the world you return to is unrecognizable. Time travel isn't just a technical problem, it's a moral and existential one. Could humanity handle the responsibility of bending time without destroying itself? Despite all these tantalizing possibilities, there are strong reasons to remain skeptical. The energy requirements alone for macroscopic time travel are mind-boggling. Our current understanding of physics doesn't allow for stable, traversable wormholes or safe manipulation of cosmic strings. The paradoxes of backward time travel might suggest that nature simply forbids it. And yet, science often surprises us. What once seemed impossible, like heavier-than-air flight or instant communication across the globe, is now part of everyday life. Could time travel be another frontier waiting for humanity to unlock? Interestingly, time travel isn't just theoretical. Its echoes appear in experiments and real-world observations. GPS satellites, for instance, must account for time dilation effects. Moving clocks tick differently in orbit than on Earth, or else our navigation systems would drift by kilometers every day. In a sense, these satellites are tiny time travelers, nudging forward or backward by fractions of a second. And particle accelerators, where subatomic particles approach light speed, regularly demonstrate relativistic effects, confirming that time is indeed flexible and relative. The universe has already given us glimpses of what Einstein predicted, and it hints that we're only scratching the surface. Science fiction often imagines time travel as flashy machines or mystical portals, but the real universe is far more subtle and fascinating. Instead of turning a dial to jump centuries ahead, we might one day manipulate gravity, velocity, or quantum states to stretch and compress time in ways we can barely imagine. Visualize a spacecraft gliding along the curvature of space-time, its passengers witnessing centuries pass outside the windows in mere hours. Picture sending a quantum message into the past, whispering secrets to an earlier version of reality. The possibilities challenge our intuition and ignite our imagination, making us reconsider the very nature of existence. And yet, the ultimate twist might be this. Perhaps time travel is happening all around us, but in ways we cannot perceive. Some physicists speculate that closed time-like curves could exist in distant corners of the cosmos, or that the universe itself might contain hidden loops where events repeat or converge. What if distant civilizations have already mastered time manipulation, observing or subtly nudging the flow of events? Could historical anomalies, déjà vu, or even the peculiar behavior of particles hint at time's malleable nature? While we may not ride a DeLorean or step into a glowing portal anytime soon, the universe itself is a laboratory, and time is a playground far stranger than fiction could capture. In the end, is time travel actually possible? The answer is nuanced. Traveling into the future, even if only by tiny increments, is real and observable. Traveling to the far future might one day be achievable with near-light speed travel. Traveling to the past, however, remains speculative, tangled with paradoxes, extreme energy requirements, and exotic physics we have yet to harness. Yet, science is ever evolving. What seems impossible today might be tomorrow's breakthrough. The universe continues to surprise us, and every discovery brings us closer to understanding the true nature of time. So, the next time you watch a time travel movie, remember, it's more than just entertainment. It's a reflection of humanity's curiosity, our desire to explore the limits of reality, and our fascination with the cosmos. Time travel may not be as simple as hopping in a machine, but the science behind it is every bit as thrilling and far more mind-bending. The universe is a stage where time itself dances, twists, and bends in ways that challenge everything we thought we knew. And who knows, one day, humanity might not just observe the flow of time, but step into it, journeying to the edges of the past and the far reaches of the future. If this journey through the mysteries of time has captivated your imagination, don't stop here. Share your thoughts in the comments below. If you could travel to any moment in history, where would you go? Hit that like button if your mind is buzzing with cosmic possibilities, and subscribe to Cosmic Horizon Hub to join us on more explorations into the wonders of the universe. Together, we'll venture beyond the stars, dive into black holes, unravel the mysteries of dark matter, and perhaps, one day, uncover the secrets of time itself. The universe is waiting, and time is just the beginning.